Before we plunge into the declaration, it's critical to comprehend what molecule gas pedals are. The enormous Hadron Collider, LHC, operated by CERN, is a 17 kilometers ring of superconducting magnets and the world's biggest and most impressive atom smasher. It represents the zenith of human logical accomplishment. In fact, it's strong to the point that it can reproduce the actual states of the universe's introduction to the world. Yet, could this machine, intended to open the insider secrets of the universe, hold the way to something undeniably more unfavorable? CERN, established in 1954, is one of the world's most renowned research associations, with 23 member states and great many researchers. It's a center for collaboration and development. The LHC is CERN's lead project, yet it's only one piece of a huge network of gas pedals and experiments. Imagine a circuit, not so much for vehicles or ponies, but rather for subatomic particles, in a test of skill and endurance in space itself. The LHC speeds up protons to almost the speed of light, sending them on a crash course that imitates the energy of the universe at the time of the Big Bang. The impacts create temperatures multiple times more intense than the center of the sun. Large numbers of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC are made to crash at 4 locations around the gas pedal ring, corresponding to the positions of 4 molecule detectors: MAP, ATLAS, CMS, ALICE, and LHCb. Each fills an exceptional need, investigating various parts of particle physics. Together they act as giant cameras, capturing snapshots of these crashes. Scientists then sift through the debris, searching for indications of the elusive Higgs boson, otherwise known as the God particle, and other phenomena that offer hints to the universe's key building blocks. By studying the microcosm, we gain insights into the cosmos, yet with each answer comes another question, and with each discovery another test. The LHC isn't merely a scientific instrument. It's a demonstration of human curiosity and advancement. It embodies our persistent quest for knowledge and our craving to grasp the central forces that shape our universe. But as we push the limits of what we know, we must also consider the moral and existential questions that arise. What are the dangers of testing the unknown? Might our mission for understanding inadvertently open forces we have no control over? In the hallowed halls of CERN, where the limits of human comprehension are continually pushed, a discovery has arisen that sends a shudder down the spine of even the most prepared researchers. Brian Cox, a former scientist at CERN and a voice of authority in the realm of particle physics, has recently made a statement that has left the world both fascinated and fearful. Cox's words resound with haunting clarity. The objective of CERN's Large Hadron Collider is to reproduce a miniature Big Bang. Yes, you heard that right, a small version of the very event that brought forth our universe. The physicist also went on to explain the implications of this objective, highlighting the LHC's unprecedented potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine harnessing the power of creation, the ability to summon the very essence of the universe. It's an enticing possibility, but one laden with danger. The miniature Big Bang isn't a hypothetical concept. It's a tangible reality within the LHC. The temperatures, the pressures, the raw energy, all mimic the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong back in 1978. The Russian physicist Anat Borsky experienced an accident that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally come into the direct path of a proton beam. The beam, with a force that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was miraculous. He saw a flash brighter than 1,000 suns but had no worries. The beam's path caused widespread tissue damage, passing through bone and tissue, yet he remained conscious and even walked to the hospital for treatment. The result was both horrifying and fascinating. The beam caused limited tissue death, leading to hearing loss in one ear and partial facial paralysis. But remarkably, Borsky's cognitive abilities remained intact, and he continued his scientific career. This incident isn't a personal tragedy but a cautionary tale that underscores the massive power and potential risks of particle accelerators. The dangers of an atom smasher like the LHC are not to be taken lightly. The potential for unexpected reactions, for manipulating the very fabric of reality, are not the stuff of science fiction but real concerns voiced by some in the scientific community. One of the most disturbing and enthralling concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The fact that the LHC could create such an entity, even on a minute scale, is shocking to both the public and scientists alike. Could this black hole, in theory, grow uncontrollably, consuming the Earth from the inside? However, researchers at CERN have assured that any black hole created would be unstable and would dissipate instantly. Yet, the remote possibility has sparked debates, fears, and awe at the power we wield. It's important to understand how the LHC could create a black hole. It involves the basic mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and warps, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. This is a simplified analogy for what might happen in the LHC. In the realm of quantum physics, where the laws of the universe are both strange and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational well that forms a tiny black hole. This perplexing dance of particles has even caught the attention of several prominent scientists, including the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels. This instability could lead to a catastrophic vacuum decay event. A catastrophic event that wouldn't just destroy the Earth but the entire universe itself. What's more, concerns encompassing the exercises of the LHC stressed the presence of thorough security estimates, broad reviews, and protocols that ensure its operations are conducted with utmost care. Cox reassured that the energies involved are well within what the Earth naturally experiences, and the possibilities of creating a stable black hole are cosmically low. Even if one were created, scientists say it would be so small and unstable that it would vanish instantly, a phenomenon predicted by Stephen Hawking, known as Hawking radiation. Such an event would be a transient moment of cosmic wonder, a brief glimpse into the void, and then gone. Some have gone further, hypothesizing that the LHC's experiments could open a portal to another universe or dimension. This idea, though largely dismissed by the scientific community, has captured the imagination of many and has become a subject of intrigue, fear, and even myths. What lies beyond our world? Could we inadvertently unleash forces or entities we don't understand? The notion of opening a portal to hell has been dramatized in various media, fueling uncertainty. But how did this idea emerge, and what does it mean in the context of scientific exploration? The concept of parallel dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These additional dimensions could be compactified or hidden from our perception but might theoretically be accessed or revealed under extreme conditions. Now imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples or tears in the fabric of spacetime, offering a glimpse into these hidden dimensions. This idea has sparked both awe and fear. It's not just the possibility of creating black holes that haunts us. It's the potential for opening pathways to the unknown. As we venture further into the realm of particle physics, we face profound questions about our place in the universe. Can we control what we discover? And, more chillingly, can we close the door once it's been opened? The announcement by Brian Cox about the LHC's goal to recreate a miniature Big Bang should be a moment of scientific triumph. But, as with all great advancements, it comes with its share of risks and uncertainties. With each new discovery, we inch closer to the edge of the unknown. In this quest for knowledge, we must remain cautious and vigilant, for the greatest discoveries often leave us questioning whether we should have looked at all. Brian Cox's declaration about the LHC's objective to recreate a small Big Bang resonates throughout the scientific community. It serves as both a beacon of achievement and a source of existential reflection. The ambition to simulate conditions like the birth of our universe, to glimpse into the very origins of space, time, and matter, is an extraordinary leap in human exploration. Yet, as we delve deeper into the universe, we must confront the profound responsibility that comes with such power. The LHC is a technological marvel, a symbol of humanity's ingenuity. Its purpose is not just to test the fabric of the universe but to uncover the hidden balances and mysteries that govern all we know. By smashing particles together at unprecedented speeds, scientists can study the fundamental forces and particles that shape the universe, from the Higgs boson to dark matter. However, every experiment, no matter how carefully controlled, comes with unknown variables and unforeseen risks. The fear of accidentally triggering a catastrophic event, such as the creation of a stable black hole or the collapse of the quantum vacuum, reflects deeply rooted anxieties about the potential negative consequences of scientific discovery. While the chances of such a disaster are infinitesimally small, the implications of even a tiny risk are terrifying. The world has already witnessed the destruction that human actions can cause, from environmental crises to nuclear weapons. Now, the fear is that we may be toying with forces too vast for us to comprehend or control. In addition to the potential dangers of the LHC, there is an ongoing philosophical question. What is the cost of knowledge? Are we willing to face the consequences of probing too deeply into the fabric of reality, of possibly uncovering forces meant to remain hidden? What if, in our quest to understand the universe, we trigger a chain of events that spiral beyond our control? In the pursuit of scientific progress, it is essential to balance curiosity with caution. While the LHC has brought us closer to understanding the fundamental components of nature, it has also forced us to reconsider the ethical implications of tampering with the very building blocks of existence. Moreover, the idea of opening gateways to other dimensions, whether accidentally or by design, presents a speculative yet fascinating concept that stretches beyond the realm of hard science. Could the collision of particles at such high energy tear open the fabric of space-time, potentially linking our universe to others or even exposing us to entirely new forms of existence or unknown forces? The mere possibility raises unsettling yet intriguing questions about the nature of reality itself. Are we truly prepared to handle what might lie on the other side? Or have we already reached a tipping point in our pursuit of knowledge? At the same time, it is important to note the reassurances of scientists involved in the LHC's experiments. They have repeatedly stated that the safety protocols and comprehensive risk assessments conducted at CERN ensure the utmost caution. They argue that the likelihood of a catastrophic event is negligible, and the energy levels involved, while extraordinary, are well within the range of what naturally occurs in cosmic collisions, such as those in supernovae. Although the LHC might create conditions that are extreme by human standards, they are not unique in the grand scale of the universe. Nevertheless, the perception of risk remains. The allure of scientific advancement is tempered by the ever-present question of whether we are pushing too far, too fast. As we stand on the brink of this new era in scientific discovery, the need for transparent dialogue, thoughtful regulation, and careful consideration of the ethical and existential risks associated with the LHC becomes even more critical. Should we continue to expand the boundaries of knowledge? Or is there a point where humanity must pause and reflect on the consequences of its actions? These questions are not easily answered, and the tension between scientific curiosity and caution will remain a central theme in the future of particle physics. In the end, the work being done at CERN is a testament to the boundless nature of human curiosity and our drive to understand the universe. But with great knowledge comes great responsibility. The very forces that allow us to unlock the secrets of the universe also have the potential to reshape everything, from the fabric of spacetime to the fate of our world. We must approach this